Hello, I'm Carlin, and our paper for OpenSym 2021 is Extracting and Visualizing User Engagement on Wikipedia Talk Pages. We started this project as although all user data is available for download under a free and open license, there is no top-down guidance for how to access it. This is especially important as the Wikipedia history dumps come as roughly 50 GB XML files. Even with many curated lists of tools, we could not find one which provided an efficient way to work with this data. To tackle this issue, we created the following research questions. How can the Wikipedia dataset be made more accessible? Do visualizations of the data provide insights into differentiating user groups? And does the metadata alone provide enough context to classify blocked users? These correspond to the three main outcomes of our project: our tool, namespace database, the visualizations of the resulting database, and our attempts to classify blocked users. First, our open source Python tool, namespace database, automates the process of creating a database of edits for a Wikipedia namespace. It finds the fastest mirror, downloads and extracts each dump sequentially, splits each into partitions, extracts information about the dumps in parallel, and then inserts this data into a MySQL database. We rely on MWXML to stream in the partitions and WDiff to find the added and deleted text for each edit. We chose to run namespace database on namespace 1, the article talkspace, as we expect there to be a large diversity in editor engagement since editors collaborate and argue on talk pages. The resulting database was 83 GB and has four main tables: edit, page, user, and partition. Edit is the largest table and contains the added and deleted text of each edit, plus calculated metadata values. The page table stores information about articles, like the title, namespace, and number of revisions. The user table keeps track of overall metrics, like number of edits and reverted edits. Finally, the partition table provides bookkeeping for the processing tasks. This database took 132 hours or 5.5 days to create. In order to achieve this, we used external computing resources with a total of 84 cores. Based on our benchmarks, we predict that the database could be created with several weeks of constant processing using a personal computer. However, disk space is the main bottleneck, as 100 GB of space should be free per dump. Our second research question addresses the usefulness of our database. Can this data be used in meaningful ways by researchers? We therefore created over 40 visualizations and focused on understanding user engagement through the lens of user groups. Our 6 groups of interest are users, blocked users, special users, IP users, blocked IP users, and bots. Special users are users that have been given certain permissions, like being able to protect pages or roll back many edits at one time. In this first example, we look at the composition of these user groups. Both columns in this graph are percentages of the total. The left is the populations of the group, and the right is the number of edits they make. From this, we can see the inverse correlation between group size and the number of talk page edits made. IP users, the biggest group, make a comparatively small number of edits, and special users, one of the smallest groups, make the most edits. Next, we show how these change over time. The top chart is the population of these groups, while the bottom is the number of edits they make. We can see that both peaked in 2007 and the population has steadily plateaued while the number of edits steadily declines. Now, we look at the length of time that talk page editors are active for. The first and last edits of each user are plotted with the total number of edits they have made encoded by the hue of the point. A dense group of editors is apparent in the year 2006 to 2008. We can break this down by user group and see that special users tend to continue editing, while block users don't stick around for long. We now consider this novel chart which shows the impact of users that started editing each year. The bars on the right of this graph show the average edits per year that they have made. This allows us to see the outsized role of special users that started editing in 2006. They make more edits per year on average than all groups of users combined that started editing in 2009 to 2016. In this figure, we investigate when user groups edit in the year, in which we can see a large drop in editing over the winter holidays. Also, we can see that blocked users tend to be the most active at the start of the academic year in September. In terms of metadata associated with the edits, this visualization shows the average values for each user group. The metadata values we chose were informed by Javan Mardi et al. And focus on detecting spammy edits. Of note is the high amount of blanking of talk pages, vulgarity, and reversions of IP and blocked IP edits. Special users insert the least amount and get reverted the least. Bots have the longest edit comments on average and insert the least vulgarity with special users. Finally, we demonstrated an avenue of research that's possible with this data by trying to classify blocked users. We wanted to see if edit metadata was enough to classify blocked users, but found that the trends in the average did not select for individual group members. We hypothesized that perhaps taking the difference with their most recent edits would show a pattern that could be detected. As we can see, this looks promising as there is a high number of reversions in their most recent edits, so perhaps the other features also select for blocked users. However, when we compare with other user groups, reverted is the only feature on the extremes, and therefore we can't linearly classify them using the strategy. We verified the difficulty of this task by clustering the average features of each group using the centroid distance function. We visualized this using a dendrogram, and the lower clustering is, the more similar they are. We can see that blocked users and users are the most similar on average and are therefore harder to separate and classify. In review, we can confirm the first two research questions, that we made the Wikipedia dataset more accessible for research, and that visualizations of this data provide insights into differentiating user groups. Unfortunately, we cannot confirm the third, but in the future, we could improve our classification with machine learning or by adding additional metadata like keywords. Second, expanding our dataset to mainspace would be fruitful for further investigating user group engagement with Wikipedia. Finally, it would be of interest to investigate how wiki projects develop and change over time, perhaps informing us about the structure of successful projects. Thank you for watching, and check out the project at the link if you are interested, or for more details, check out our paper at OpenSym 2021.